Hello everyone, welcome to another video. In today's video, what we're going to do is sort of a semi-demo in the sense that we're not building anything new, but we're going to go over the process of building a sequence diagram for a fairly simple system that we built a couple weeks ago. Now, if you guys do not remember, I'm going to put a link to the stopwatch video, and that's what we're going to be creating a sequence diagram for. Now, of course, to keep the video short, I picked a system that is fairly simple, but as you would see that typically detailed sequence diagrams could get pretty complicated very quickly. So what you try to do is try to simplify, try to basically capture the most important parts of the sequence instead of trying to capture everything. Okay. But today we're actually going to try to capture as much of that sequence as possible because the stopwatch system was not very complex. So let me share this screen so you give you a quick reminder of what we're talking about. So we had created this stopwatch a couple weeks ago. Here is our model, which had a stopwatch class with methods like play, pause, reset, and getting the current time. It included a bunch of timekeepers. Now, we only used one, but if you want to keep track of laps, you can have multiple timekeepers. That's why we had created an array. So that's why you have one-to-many relationship between stopwatch and the timekeeper that was used. We were displaying the times on an LCD display. We were using two buttons one of them to start and stop the stopwatch and the other one to reset the stopwatch. So that's why you have a 1-to-2 relationship here. And then a controller that brings the model and the views together. So that was our design. So here is the implementation of it, just so you remember how it was. So here is our stopwatch. And when I run this stopwatch, it is going to show a 0. And then I click on the green button and the stopwatch starts running and it continuously shows the time. And I'm going to click on the green button again. The stopwatch stops and it's no longer showing. And then finally, I could start it again, but if I just click on the red button, that resets the counter and shows 0. So that was basically the system that we built. Really simple, but as you would see, the sequence is not, when you draw it out, it becomes fairly detailed. What we're going to do is, in order to show the proper sequence, when I was programming this, we did take a couple of programmer shortcuts. And if you are used to programming or if you are okay with Python, you probably wouldn't even think twice about it. But for those of you who are new to Python, I just want to show you a couple of shortcuts that we did, and we're going to sort of expand these out. For example, this one. This is actually a fairly, a number of things that we did do here. So I basically just say self-display show text, self-stopwatch current time. Makes sense, right? I'm showing the current time of the stopwatch on the display. Well, really what we are doing is the sequence of it, for those of you who are new to Python or new to programming, might be hard to see what exactly is going on. But remember, this happens first. So we are getting the current time. So let's just say current time equals this one. So this is what we are doing first. And then we are displaying whatever we got on the display. So this one line is equivalent to these two lines. So for those of you who are new to Python, remember that this is a nice little shortcut that programmers like to use, one line to represent two lines, plus we are sort of saving a variable. Of course, it makes no difference. The optimizer will drop this variable right after this you get out of the run. So it's not that big deal in terms of programming efficiency. This is just as efficient as the other one, but this is definitely a short way of doing the same thing. You can see the same thing happening here as well. That's actually exactly the same line. It's almost like a duplicate of code. So what we could do is we could copy paste this. Now, of course, I'm not a big proponent of copying pasting, but since this is what we did last time, and it's basically just a one line of code and it's okay to do. Otherwise, what you would do is create another method to do this one line thing, which may be a little too much. Here is another example of a shortcut that we did, for example, here. To get the current time from a stopwatch, what we did was we just said return str of the timekeeper. Seems pretty logical, but basically just remember that what we are doing is getting current time is str self.timekeeper, which, as you know, we'll call the string conversion method, and then we are returning current time. And that's basically what that is doing. So as you can imagine, as a programmer, this is, of course, a lot simpler to write one line of code instead of creating a new variable and then dividing up. But when we are doing the sequence, having it this way is going to make it a little easier to understand the sequence. Otherwise, you'll question, why did we do it that way? So now, given that, obviously we can run it again and you will see that it makes no difference in terms of the running. It works exactly the same way. We click on the green button to start. We click on the green button again to stop, and we click on the red button to reset. And that's basically how the stopwatch works. All right, so now let's go ahead and build this sequence diagram. Now, there are a couple of things that's going on in the sequence. First, if you look at the main.py, which is essentially what happens every time a Raspberry Pi Pico application runs, it executes the main.py. Main.py simply creates a new instance of stopwatch controller and calls the run method on it. And so technically, this main is the initiator of the whole system, but we will just ignore that that's being happening. We will basically start with what is in run. And that's what we will start with. Assume that stopwatch has already been started. So now our initiator would be the person, the actor, who actually pushes the buttons. Okay. So let's get started with creating this diagram. So I'm going to go back to Visual Paradigm. We go to Diagram, click on New, and obviously sequence diagram comes up right up front because I have done sequence diagram before. If it does not, just start typing sequence and it'll be the first match. Okay, so we'll click on blank and let's call it stop watch sequence. Okay, and we're going to get a nice little empty diagram here. Now, remember, in any sequence diagram, obviously, you're going to have an actor that initiates the sequence. So we're going to bring in an actor. And you can leave it as actor. You can call the actor user, whatever it is that makes sense. So this is the person, the stick figure. This is the guy who is going to be pushing all the buttons and all of that. And then the other things that appear in the rest of this place are lifelines. And this is important to remember that this is one place where we're actually working with the objects or instances of the classes. Remember that. And because there could be multiple instances of the same class, and that does happen in this stopwatch example, and you will see that. I might to keep the video short, I might time lapse over some parts of it, but it is basically repetitive, at least creating the lifelines. Now, which way you are going to bring the objects in, it is kind of up to you. Remember that all we are trying to do is keeping the diagram as clean as possible. And it is hard to do that. And then you will see, even for a simple system like this, how complex it gets. But we're going to bring in, of course, the stopwatch controller. That's going to be our first one. And I try to use the same variable names that I use in the code itself, just to remind you that we're talking about objects here. We're not talking about entire classes. We're talking about instances of objects. So ST is our stopwatch controller, is the name of the variable or the instance of our stopwatch controller class. So what we're going to do is right click, select class, and this is important that if you already have the class diagram in the project, you're going to get the list of classes already. Now, there is a debate on what comes first. And typically, designers, we like to say that class diagram sort of comes first, but when you're doing these other diagrams like state models and class diagrams, you're going to see invariably, you're going to be, as you're building the state models or the sequence models, you may need to go back to the class model and add some methods that you thought you had enough, but you missed something. So it is always a great idea. In fact, the typical recommendation is that you build the model sort of in parallel. So you create a base class model first, and then as you are creating the state and sequence models, you expand the class model. So you're kind of doing them together. All right, so here is our stopwatch controller, and I'm going to change this lifeline to ST. So notice what happens here is we're actually representing an object called ST, and it's of type stopwatch controller. And we're going to try to do basically the same thing for all the objects we need. Now, when stopwatch controller starts running, let's see what happens. And we're going to try to bring in those classes as we need. So the first thing that it does is it basically gets the current time from my stopwatch. Okay. And then it displays that on the display. So we need the stopwatch class and we need the display class. All right. Now, if you look at current time of the stopwatch, current time calls the string converter of the timekeeper class. So we will need an instance of the timekeeper, and we call them underscore timekeeper for the instance. I'm going to drop the underscores. Hopefully you understand that the underscores are basically a notation to Python saying these are private variables, but private attributes. But as you know, in Python, there is no such thing as private attributes. All right, so let's go ahead and start. We will need the stopwatch, we will need the display, and we will need the timekeeper. So let's bring in the stopwatch. We're going to bring in another time lifeline. Let's say select class, stopwatch. And let's call this, what did we call the stopwatch? My stopwatch. All right. So I'm going to try to keep it as close to the actual code as possible so you guys can see exactly what is going on. So the syntax is you put the name of the instance, colon, and then the class that it is an instance of. Let's bring in the timeline of the timekeeper, and we call just timekeeper. Okay. So what we will do is select class timekeeper, and that's called timekeeper. So again, I'm going to keep repeating that the first one, that's the name of the instance, and then the colon, the name of the class. And you're going to see by making sure that you're selecting a class that's already created, that helps us with some of the messages. And finally, we need the LCD display. So let's go ahead and add the LCD display lifeline. And what we're going to do is select class LCD display. And what did we call the display? Just display. All right, so this is display. Notice that I'm not putting the underscore as I said, but otherwise they're exactly the same variable names as they are in the code. So now let's think about what is the run sequence. It's basically a loop. And inside the loop, there is a condition, and we can sort of combine the two, and we're going to do a little shortcut, or we don't absolutely need to. And this is a continuous loop, and inside we are doing an optional if we are running, then we're doing this sequence. Okay, so now watch how this is done. First, we are going to create a loop. We create a loop or an optional by using what is called a combined fragment. And if you, as you know, that if you click, whenever you see that little black triangle, there's alternatives in there. So you can create an alt combined fragment, which is basically just saying if then else kind of thing, or a loop combined fragment, which is basically a loop. So first we're going to create a loop combined fragment, and you basically just click and it creates the loop combined fragment. And it asks you what, uh, which classes, which lifelines does that loop involve. We don't have the user involved yet because this is basically the continuous loop. We need the stopwatch, the controller, and the display at this point. We don't need anything else. So we click on OK, and notice that it expands out to fill all of them. If you do not do this, you can manually expand all you want, but we do recommend that we put that in there. Now, this is a while true loop. So what we're going to do is we're going to go to operand, and we're going to click on operand, and our constraint is true, right? As long as the this thing is running. So notice that it puts the constraint in there. As long as this is an infinite loop, basically. What am I doing in the infinite loop? Well, we're checking to see. I'm going to expand this out a little bit. We are basically getting, if we are running, so this is where the optional will come into play. So let's go to the alt combined fragment, and we're going to drop in an alt combined fragment, and we need basically all of them. Okay. And this guy is actually inside the loop. So we're going to put it inside the loop. So this is a while true loop, and inside we have an alt combined fragment. Okay, so when you create an alt fragment, by default, it creates two alternatives. So it's sort of like an if then else. If certain condition, you do this, otherwise you do that, right? In this case, we don't really do anything for if it is not running. So if running is true, we do this. If it is not running, we do nothing. So there is absolutely no point keeping the second alternative there. Some people actually like to change this to an optional. So this is sort of an optional fragment, but we're going to keep it as alt. You don't need to worry about. Just remember, if it's a loop, whether it's for loop or while loop, you use a loop. If it's a if then else, you use alt. So to change it, you just go to operator kind, and by default, it's alt. We'll leave it that way. All right, so now what is the condition? To add the condition, what you do is you right click on this and go to operand, and you click on edit operands. Notice that it has already created two operands already for us. We only need one, so we're going to click on operand 2, and we look at operand 3 here, which we do not need. So we're just going to hit the delete button, and it's going to say, do you want to remove selected operands? Yes. We're going to click on the operand 2, and we were going to say running equals true. So this is our condition for doing the next sequence that we are going to do. Let's expand this out a little bit so we have space. Now we're ready to do the sequence messages. So what are we doing while it's running? We are getting the current time by calling current time from my stopwatch. Okay. So the first thing we're going to do is going to send the message called current time to my stopwatch. And this is from stopwatch controller. So stopwatch controller is going to send a message to my stopwatch. And you will see that when I draw the message, number of things that happen. So I'm basically going to go from one lifeline to the next. And notice that it creates, first of all, it creates the stopwatch controller. Technically, the stopwatch controller is already created a long time ago, but in the diagram, it just creates now. Also notice that because we already have the class model in the project, it gives me all of the messages to choose from. And these are the methods of the stopwatch. And we know we need to call current time. So we will say current time. Okay, so that's the message that we send. And that's number one. We are asking my stopwatch to give me the current time. What is stopwatch going to do when that happens? So let's take a look at stopwatch. Stopwatch gets current time. It's going to ask the timekeeper to convert itself to string and return that back to the controller. So the first thing is stopwatch is going to ask timekeeper to give me your string representation. So we're going to send a message, same thing, from stopwatch to timekeeper. And just like before, all of the messages show up and we are going to get the string. So we're asking the timekeeper to give me the string. Timekeeper is going to reply with the string. So here is we're going to create a reply message from timekeeper back to stopwatch saying, here's the current time. So we will say current time. Notice that this is not a method. This is a return value, right? We are asking for a string that gets back to the stopwatch. Yeah, this unfortunately keeps happening. You know, Visual Paradigm will keep trying to resize stuff, and you're going to have to fight with it to make sure it gets resized correctly. All right, so my stopwatch got the current time. It's going to send it back to the controller, right? So it's basically sending another reply message with that current time back. And it should be right there. Okay, so current time comes back from the controller and we send it back to the message. And you can kind of put them together so they're one single lifeline. So you see what happened? We're asking for the current time from stopwatch. Stopwatch goes to timekeeper and say, give me a string representation of your time, sends it back as a string, and you send that back to the controller. Now what is controller going to do? It's got the current time. Now it's going to show the current time on the display by calling show text on the display. So now we're going to expand this guy out further. We're still inside this. So we're going to expand this one there. Takes a little getting used to because the UI is very finicky. So now what we're going to do is we're going to ask the display to show it. So what we're going to do is no longer a display message, just a regular message. And we will say show text. See, there is show text and we can show the text. And we don't have to respond anything back from display. Display is sort of like a flat message that here, show this text. When it comes back, we know the text has been shown. So there is no need to show a response. So this is basically the sequence of the big while loop. So what we could do is click on this and sort of close it down here. So that's the main loop. Now that is not quite done yet. We haven't done anything about starting or stopping the message. So that's where the the second part comes into play. So let's see, how does starting and stopping work? This is where the actor comes into play. The actor is going to be the one that's initiating the start, stop, and reset, right? So what we're going to do is have the actor push the button. Now, the actor does not call methods. The actor does actions. So technically, we don't have to say a call message. It can be an uninterpreted message. You do not necessarily have to put something in here. So what we're going to do is we're going to bring in those two buttons. So let's call start, stop button. And this guy is of type button. And now, as I was telling you, that you could have two lifelines of the same class. So here is another button, and this one is the reset button. All right, so here's my start stop button and here's my reset button. Now the actor is getting involved. The actor is now going to push the button, right? So what the actor does is it sends a message to a button. Now this is a physical action, right? Saying that pushes button, right? This is not a method call. This is an actual action. Now, when that happens though, the button, notice that a button was pressed. So it's going to send the handler, which is the controller, a button pressed call. So this is kind of a reverse call that is going to happen from the start stop button to the controller saying button pressed. Okay. Now, when the button is pressed, what happens? Inside the controller, we have a button pressed, and this is where we have, notice that we have an alt, right? If name is start stop, we do something. If name is reset, we do something, right? So that's what we're going to do now. And so we're going to see. So let's just, since you have already seen alt, I'm going to probably time lapse through this part. Just follow along what we are doing. So in the time lapse, what we are doing is we are creating the alt fragment for the actual starting and stopping of the button. So we just got the actor send us the start stop message. So now we're going to check if the name of the button is start stop or reset. So in the alt fragment, the two separate alt portions, one is start stop and the other one is for the reset. Expand the start stop out so I can put another alt inside. Notice that there is an if inside another if. And there we're checking to see if we are already running. So if you're already running, then we're going to pause the stopwatch, which is going to pause or stop the timekeeper, which is that sequence that we just created. And if it was not running, so here's the two operands that I just created. So the top one was where it was running, we paused, and if it was not running, we're going to play the stopwatch, which is going to start the timekeeper. And so that's that part of the sequence. Now let's do the reset. So here, actor sending a reset, pushing the reset button. Reset is calling the button pressed again, and in there, when name is reset, what we are going to do is we're going to reset the stopwatch, and then we're going to get the current time back from the stopwatch, and whatever time we got back, we're going to show on the display. So that's essentially how it works, and expand out the lifelines to make, instead of creating these little tiny. And here is the final sequence diagram. And as I said, that even for a simple system like the stopwatch, as you can see that the sequence diagram did end up being fairly complicated. So the moral of the story is when you're building sequence diagrams, first of all, we went through and did as detailed as possible, but you kind of pick and choose what exactly is the most important part to display, because remember that the main idea is a presentation that that you want to be able to show your developer or whoever is building this what should be the order of execution of these different messages. And you notice that sometimes we will skip some things, like we already know how current time is generated. This time we didn't even worry about generating the current time. Now, what is important though, before I end the video, to show that when we are actually running this, this is actually what is happening in the system. And you have seen in the past that there are all these messages that show up in the screen. These messages are generated by my logging class. I probably should include the times of the log as well, but I haven't been all that picky about creating the logging messages. But at least let's take a look at some of the things that are similar. So I'm going to try to put these two side by side. Let's see how successful I can be with that. But let's take a look at what is happening. Let's just take a look at when start stop is pressed, and we will see how that works out. So here, notice that start stop is pressed somewhere here. Start stop is pressed, and then that goes to timekeeper start. So here start stop is pressed. The running true, of course, I did not log that part, but running, it was not running. So we're going to call play on the stopwatch, and that is going to call start. So when start stop is praised, we start the timekeeper. As you see that there is the start message to the timekeeper. And this is when this loop starts going. Running is now true. So now we are doing this loop. And let's take a look at when start stop is pressed again. Notice that we are calling timekeeper stop. So here start stop got pressed again. This time running is true. So we got call timekeeper stop. And when reset is pressed, we can reset the counter. So here reset is pressed. We reset the counter. We actually did not show that in here. Probably should have. But then notice that at one final time, we are showing the display just like we predicted it would. And then the process terminates. So the thing to notice is that when you create the sequence diagram, you can kind of verify your sequence to some extent. Not everything is logged, but at least what log messages come up, you can verify that that is the sequence that you are expecting, and that is the sequence that actually got processed. So that's how you build sequence diagrams. Yes, it is quite a bit of work, but what you do is you pick most important use cases that you would like to present, and that's the use case that you create the sequence diagrams for. All right, hope this was useful, and I will see you at the next video.